In this video, we'll be calculating the standard deviation for two sets of data to determine which one is more closely centered around the mean, or in other words, less dispersed. So what we've got are two chemistry classes and the class average on 5 different pieces of assessment, or 5 different tests. So in part out of this, we need to calculate the mean mark, or the average, for each class. When we are talking about statistics, we usually refer to the mean as x bar. And x bar for the first group you would get by adding these together, dividing by 5, which we can see in an earlier video, and we get a value of 78. If I do the same calculation here, I get a value of 78.4. So what I need to do now is calculate the standard deviation using these averages and my data. Since there's quite a bit of work involved in the standard deviation calculation, it's nice to organize our data into a table. So you'll see I've organized my class scores in column A, or the first column here. The first part of the standard deviation calculation involves subtracting the mean from each data value, so I'm going to do that in this column. And the second portion requires that I square that value that I get back once I do subtraction. So let's begin by doing that. If I subtract 78, which is my x bar, from each of the above values, I'll get these values in this column. I get 16, I get negative 22, I get 11, negative 11, and 6. Now then you need to square those data values to get this column filled out. So I would get 256, 484, 121, 121, and 36. We would then need to do the same calculation to this table. Having completed the second table for Class B's test scores, in the same fashion I completed table A, I then need to find the sum of column 3. So add up these values. So adding those values from Class A, I get 1008. Adding those from Class B, I get 35.64. So the way I then get the standard deviation is to divide this value, which represents this part of my standard deviation formula, by my number of data values and then take the square root. So I'm going to go ahead and do that. Which will give me a standard deviation for Class A of 14.2. If I do that same calculation on this side, I'll get a standard deviation of 2.67. Now comparing those two standard deviations, a lower standard deviation is better when calculating standard deviation. It means that the data is more closely centered around the mean, or more consistent in having a lower dispersion. In which, if we refer back to Class B's test scores, we can see that we go 74, 76, 77, 81, 84. These are all pretty closely clustered. But if we look at Class A, we've got 94 down to 56 and a few marks in between. So our standard deviation reflects that, where we've got a much larger standard deviation for Class A because it's more dispersed, versus a smaller standard deviation for Class B because this is more closely clustered around the mean.